Hello everyone, this is sciencehead from sciencehead channel again. This is the second part of the video for how quantum physics began, so if you haven't watched the first part of the video, watch that first. Again, if you have any difficulty understanding the video, or if you found any wrong information, please feel free to leave a comment. So, there was an amazing proof of Heisenberg and Einstein who didn't really like the proof. You guys all probably have heard of Einstein. If you have not, just remember he was a super smart physicist. Anyway, because he was treated as one of the best physicists, and he is, his opposition towards Heisenberg's proof made other scientists tempted to dislike his proofs too. By the way, in case you forgot, note that Heisenberg's proof was based on the fact that electrons have particle-like properties. Then, there was another scientist who did not like Heisenberg's method. He was Schrödinger. Yes, a guy from Schrödinger's cat, if you know what that is. He strongly criticized how using only complex equations to find electrons' location is nonsense. So, a year later, he came up with a wave equation. As the name represents, he mainly assumed that electrons have a wave-like property, with some visuals. In other words, based on electrons' wave-like properties, he was able to get a probability of where an electron is going to be at a given time and location. This was a completely different approach from Heisenberg's. Again, while Heisenberg used pure math, Schrödinger used wave property. However, they somehow ended up with the exact same results. This is very significant considering their approach was completely different. Nevertheless, since they both ended up with the same result, it was all up to scientists which equation will be used. Then, Einstein and Planck, who were the two most significant physicists at the time, publicly extolled Schrödinger's equation. This basically led other scientists to use Schrödinger's equation too. This was also because Schrödinger's way could provide visual aid and used equations that were already widely known. However, even after these huge events, scientists were still unable to find the exact location at the exact time without probability, as both of Schrödinger and Heisenberg's methods gave a probability of where the electron would be. Then, while Heisenberg was in sadness, he introduced a principle, which is named uncertainty principle. Basically, the uncertainty principle states that it is impossible to find both exact location and quantity of motion in the world of electrons. So, he went to Bohr with the principle. However, he was lacking justification for why it is impossible. Then, Bohr helped him to explain why part of the principle by using duality of waves and particles. Meaning how electrons in fact have wave and particle-like property at the same time. This was from the fact that Heisenberg's equation, assuming electron has a particle property, and Schrödinger's equation, assuming electron has a wave property, had the same results. This was a very bold claim back in the day, because before quantum mechanics existed, it was impossible to assume such a thing has both properties at the same time, especially how properties of waves and particles are completely opposite. However, scientists were already struggling with how the world of quantum domain, meaning a world of extremely small matters such as electrons, traditional physics no longer applies. So his claim was supported, and Bohr eventually published the complementarity principle. It was that despite the concept of waves and particles being completely opposite, and in fact they cannot show up at the same time, they also often make up for each other. Thus, in a quantum domain, depending on the way of observation, some matter such as electrons could have both wave and particle-like characteristics. Now, today, it is called the Copenhagen interpretation, which is basically a composition of complementarity principle and uncertainty property. Thus, it is not that electrons are wave and particle at the same time, but it could be considered as either one depending on the experiment. This has created a huge paradigm shift in a world of science. In addition, this complementarity principle has also explained several pre-existing theories back in the day, and even today. So, this is the grand start of quantum physics, which is the study of properties and characteristics of particles that are even smaller than microscopic organisms, like electrons. Although this Copenhagen interpretation was also criticized by Schrödinger again, and even Einstein, that is the other story. Thank you very much for watching my video, and please leave a comment for any error or questions. Also, if you'd like to know any further topic in any science field, feel free to comment, and I'll see you in the next video. Also, if you haven't subscribed yet, please subscribe and like.